Okay, let's try another example. Let's make this example 2, and this is a U try. So copy it down and then try it out. So a cannonball is fired across a flat field at an angle of 30 degrees with an initial speed of 111 feet per second and an initial height of 34 feet. Write a set of parametric equations for the motion of the cannonball. Determine how long the cannonball was in the air. Determine how far the ball traveled in the air. Determine when the ball reached maximum height, and determine what that height was. And for this example, I use I's. That's okay. All right, we can change that to A's. I like A's better. Okay, so let's try the first part. Let's write a set of parametric equations. So you can pause it here, try it, and then come back and check it. You can try it all at once and come back and check it all. That's okay. All right, so then let's start with, well, let's see what's different between this problem and the previous problem. So we're given our angle, theta. We have our velocity vector. We have our initial velocity. But we're also given a new piece of information. Now the cannonball is not on the ground. It's not at 0, 0, but it's somewhere up 34 feet. And then it's, how do you draw one of these things? It's, let's just draw the ball. Okay, so then it's launched into the air, okay, as a projectile. So then let's write a set of parametric equations for the motion of the cannonball. Well, our formulas are still the same. We still have x equals velocity cosine theta times t, and y equals velocity sine theta times t minus the constant of acceleration, t squared. But now our y equation has gone up 34 units. So all we need to do is add a plus 34 at the end. Okay. All right. So then let me move this down, give us some space. All right. So let's write an equation for our x value. So v is 111 feet per second cosine of 30 degrees times t, and this is in feet. And y is the same value, sine of 30 degrees t minus 32.172 t squared, and just add a plus 34 so that our equations shifted up 34 units. Okay. So then let's simplify. X equals 111 cosine of 30 degrees, it's root 3 over 2 feet. Y equals 111 over 2 t minus 32.17 t squared over 2 plus 34. Now we have a parametric equation for, or a set of parametric equations for the path of this cannonball. Okay, let's try the next one. Let's call that B, just to be consistent with the previous problem. And then C, D, and E. Okay, so let's determine how long the ball was in the air. So we're going to graph this. Okay, This time I'm going to use Desmos, if you guys don't mind. So let me switch over to Desmos. Let me find it first. Let's see, how do I do that? Well, I guess I can get the Desmos app. All right, give me a second to do that. I'll be right back.